In this video, I'm going to talk about the advantages of combining turbocharger with a gasoline direct injection system. In the year of 2020, all the powerful engines are powered by gasoline and they use this direct injection strategy as well as they have forced induction system. As we all know, the gasoline direct injection system, we are using an injector that is directing the fuel into the combustion chamber. That is why it is called GDI. Combining the turbocharger and gasoline direct injection system results in engine downsizing, and we have developed an engine that is capable of producing higher brake mean effective pressure compared to a normal multi-point injection engine. So what is the result is higher brake mean effective pressure means higher mechanical loading. So we have to develop the engine that is capable of handling that much higher mechanical loading, and the new material technologies have the advantages for that. By injecting the fuel directly into the combustion chamber means there is less time for forming a homogeneous mixture. For overcoming this defect, we are using higher fuel rail pressure and higher fuel pressure. The higher pressure means the fuel can easily penetrate into the fresh air and form a homogeneous mixture just like the port injection system. Combining a turbocharger with an internal combustion engine will not only increase the mechanical loading, it also increases the thermal loading too. The direct injection strategy will have an additional advantage for working against the higher thermal load. I am going to explain how the gasoline direct injection have the advantage over the thermal loading that is generated by combining with a turbocharger or the forced induction system. This is also due to the higher brake mean effective pressure that is created in the engine due to forced induction. The second set of advantage by combining the turbocharger with the gasoline direct injection system is providing a turbocharger will boost the pressure and consequently the brake mean effective pressure, which will directly lead to higher thermal load. But the direct injection strategy inject the fuel directly into the cylinder, which will reduce the temperature of the fresh air that is injected into the engine, and at the end of combustion stroke the overall temperature of the mixture will be reduced due to the direct injection, so we can easily use higher compression ratio to produce higher efficiency. Higher combustion ratio means higher thermal efficiency. That means we are effectively converting the energy of fuel into mechanical energy, which will consequently improve the performance, including higher fuel economy. So by combining the GDI with turbocharger, we have additional advantages of higher performance and fuel economy. Normal gasoline engines that is using port fuel injection system will have another defect. At very high speeds, the exhaust gas temperature will rise, and the higher temperature of the exhaust gases will damage the blades. So for preventing this from happening, we have to enrich the mixture that is using at higher temperature to provide a slightly cooling effect in the blades of the turbine that is used in turbocharger. But in a GDA system, we have additional advantage due to the higher compression ratio. Higher compression ratio means higher expansion ratio. That means we are effectively converting the heat that is generated during the combustion process into useful work, which means the temperature after the expansion stroke will be very low compared to that of the port fuel injection system that is having a lower compression ratio. The higher expansion ratio means the temperature at the time of exhaust valve opening is low. That reduces the inlet temperature of the turbine, so the turbine blades will be protected, so we don't need to use an overreaching strategy for protect the turbine blades from overheating. So there is an additional advantage by combining GD with turbocharger, which will reduce the fuel consumption by avoiding the necessity of fuel enrichment at higher engine speeds for protecting the turbine blades. So additional fuel economy will be provided by combining these two marvels in engine technology. Variable valve timing and variable valve lift is not a new technology for internal combustion engines that are running today. So by combining the TGDI with VVT system helps to boom the advantages of TGDI again. It will help to provide better higher valve overlap, which will increase the scavenging process. A better scavenging process means there will be very low exhaust gas dilution and we can easily provide better power from the mixture. Fitting a turbocharger into the engine will help to increase the scavenging process because of the relative pressure difference that is created between the inlet plenum and the exhaust plenum. So additionally, the gasoline direct injection helps boost the effect compared to normal port fuel injection system. If the valve overlap is increased in a port fuel injection system, there is a higher chance for the hydrocarbons to escape through the exhaust valve of the engine. But if we are using a gasoline direct injection system, by providing the higher valve overlap, the higher pressure inlet charge from the compressor output will help to scavenge the exhaust gases out through the exhaust valve, and the fresh air also helps to cool the engine part as well as the exhaust part, and we can only inject the fuel after the closure of exhaust valve. It is not possible with a port fuel injection strategy. With the combination of these two, we can also reduce the turbo lag of the turbocharger by providing camshaft facing to control the valve timing. The valve timing, with the help of a turbocharger, we can provide a better scavenging process, so we can easily control the turbine speed by providing valve overlap, as well as with a change in load or driving demand, we can control the turbocharger by controlling the flow of air, whether the exhaust or inlet air. Is to control turbine speed means we can easily control the turbo lag, and we can reduce the turbo lag, so we will get higher acceleration and the engine will respond with respect to the need or necessity of the driver that is operating it. The increase in air mass flow rate that is got by using the turbocharger will helps to convert all the carbon monoxide into carbon dioxide, which will helps to control the emission that is from the internal combustion engine. And also we can also increase the turbine work if we have exhaust valve facing system. By using exhaust valve facing, or we can, if we are, it is possible to control the exhaust valve timing, we can increase the advance of exhaust valve opening. Earlier exhaust valve opening means higher enthalpy charge flow into the turbocharger turbine, so we can easily convert the enthalpy energy in the exhaust gases to work for producing more boost. Consequently, better throttle response will be getted from a TGDI engine. You might be noticed that turbocharged gasoline direct injection vehicles are able to produce higher torque at slower RPM, just like diesel. They are able to do this because of the cooling effect that is produced by better scavenging and better reduction in exhaust gas dilution, as well as the reduction in turbo lag, due to the reason that I have already explained before. And this all advantage helps the engine to produce higher torque at very low RPM. The reduced turbo lag and cooling effect not only increase the low end torque of the engine, but also reduces the probability of knocking. So we can also run the engine much faster to produce more power from the same engine. If we are able to run our engine as a flex fuel vehicle by injecting the alcohol fuel to the inlet valve closing time, we can increase the resistance to knocking of the engine, and we are also able to use a low octane fuel and to improve the performance of the engine. The engine will be also equipped with a swell control valve or a high tumble flow valve to increase the fuel vaporization and proper mixing, and the pressure of the fuel is also raised to 120 bar to get a higher fuel penetration and better to make a homogeneous mixture. Let's conclude all the advantages of combining turbocharger with a gasoline direct injection system. The first one is the evaporative effect, which will provide a cooling effect for the fresh charge at the end of compression stroke or at the time when the fuel is injected, because of the heat transfer that is happening due to the vaporization of fuel. And second one is high brake mean effective pressure, or BMEP, and high injection pressure that is used in GDI system. And the third one, we are able to use high combustion ratio in gasoline direct injection system engines. And fourth one is the lower exhaust valve opening temperature and low turbine inlet temperature will help the turbine to work at very high speeds without the danger of getting thermal attack from the hot gases coming out of the engine. And higher fuel economy can be produced by a turbocharged gasoline direct injection system, and better scavenging is another advantage of gasoline direct injection engine. And turbo lag is reduced by combining turbocharger with gasoline direct injection system, and lower carbon monoxide emission is an achievement by the higher mass flow rate into the combustion chamber due to the forced injection system as well as the variable valve timing system, and reduced knocking tendency as well as low speed torque is another great advantage. I hope you must be able to tell the advantages of combining turbocharger with gasoline direct injection system now. Don't forget to subscribe to my channel for watch the updated videos at the earliest, and don't forget to hit the bell icon for get notified when I make a new upload. So thank you for watching and have a nice day.